Hello, my name is Billy York. I work in Cloud and Data Center, specializing in monitoring and automation. And today I'll be talking to you about monitoring your barbecue with Log Analytics and Powershell. Using Powershell to extract, transform, and load our data into Log Analytics, we can build a full monitoring solution. I come from an infrastructure background, but what ended up happening is I kept getting sent into these meetings with clients and other people where everyone was talking about API this and API that, and I had no idea what people were talking about. So I set out to change that. And this is especially useful now with more and more IoT devices coming out, or switches, or any other devices that have an API that you can query. It's becoming more and more common, infrastructure people having to do a little more programming or quote-unquote development. Within PowerShell, we have two main ways to query a web server or API: Invoke Web Requests and Invoke REST method. And in my research, I actually found that one is better than the other for certain things. Invoke REST method is really useful if your return values are JSON or XML, as it automatically converts that data to PowerShell objects. Invoke Web Request is useful if you have to parse a web page for specific data. To ingest data into our Log Analytics workspace, we need our workspace ID and primary key, which can be found under Advanced Settings in the Azure portal. We'll also need the OMS Ingestion API module for PowerShell, which can be easily installed using install module. And then we have to name our log type when we send the data to Log Analytics. For this instance, I've called it barbecue. And any custom log that you send to Log Analytics will be appended with _CL. Next, as I mentioned before, I'm using the CyberQ Wi-Fi as my IoT device, and what I've done is built a small parameterized script that allows me to query the web service on the CyberQ Wi-Fi. I have my parameters, which are my type of cook, where I specify briskets, poultry, pork butt, and pork roast, and then I also have the ability to name my cook. One thing to consider when you're building your payload for JSON, which we send to Log Analytics, is to add in any type of data that can be defined. For instance, because I've set the type of cook, brisket, poultry, or pork butt, or pork roast, I can then query that each one of those separately very easily with the where statement within Log Analytics. Next, I have a PowerShell switch where I define each setting for the type of cook that I'm doing. For instance, for brisket, I want my pit temp at 225, my target temp is 205, and then it sets the name and the type to brisket. And if you're not familiar with a PowerShell switch, it's really an advanced if statement, and Kevin Marquette has a really nice blog post on everything about the PowerShell switch, which I've included in the slide here. Next, the script takes the parameters that I've set and posts that to the CyberQ Wi-Fi. It will use the Invoke Web Request to my IP address, and I'll post that to the web service. Next, I have a do-while loop where my barbecue status I'll get with the Invoke REST method. Again, because it's returning an XML, I want to use Invoke REST method because it automatically converts those objects to PowerShell objects. But then I'll use barbecue targets with Invoke Web Requests because the way the web service is built, it's just serving up an HTML web page that I have to parse to get the current temperatures. And then I extract that HTML and I get the status for each probe, which are my pit temp and my food temperatures. and then convert those to PowerShell objects that I can add to our JSON payload. And finally, I take the status from the XML and get that data. The status temp comes in weird, so I have to divide it by 10 to get the actual temperature. And finally, we'll build the JSON payload with all of our PowerShell objects. Whenever we're sending our logs to Log Analytics, it needs to be a valid JSON payload. And whenever we send to Log Analytics, we need to get the timestamp. Otherwise, the API will reject the file. We'll then use send OMS API ingestion file with our customer ID, which is our workspace, and our shared key. And then our body is our JSON payload. We have our log type, and then we have our timestamp field. So we have all this data. Now what do we do with it? So now that we're sending all of our data to Log Analytics, what we've done is create a new custom log, which will show up here under the schema. And you can see I have my BBQ CL, which will show us all the possible fields contained in that table. If we want to query it, we simply do BBQ CL, and we press Shift Enter, and it's going to return our logs within the last 24 hours. Just one thing to note is that it doesn't always return them back in order. So unless you specifically sort them in the query to return back in order. So this should be our top log, or our last log entered. And you can see our target temp is currently at 325 degrees. The fan output is at 9%. Our food one target is 145 degrees. And our current food temp is at 119. But that's all good, but what else can we do with it? Well, we can separate out and just get one thing, which is our pit temperature, which is 322 degrees. We did that by separating out where our cook name equals pork roast, and we projected our pit temp and target time generated, and then we sorted by time generated descending, and the top one by time generated, and then just projecting the pit temp. We can also graph by simply adding a render time chart after we summarize our food data. When you summarize an average of any field, or you can sum the fields, or there's a whole bunch of different aggregation functions that you can do, but when you summarize a field, it's going to append the aggregation function that you're doing to before the field. So it's going to create a new field for this called average underscore food one temp, and you can see that right here. Average food one temp is right there. And then we summarize it by our different fields. If you don't include anything after this, it's just going to be that one field. And you can also bin by time generated, in which case I've done it by 1 minute. That's probably a little aggressive since I'm only sending the data in every 1 minute. And then we can do render time chart, and that's going to graph it out here. You can also pin this to an Azure dashboard if you wanted to, or we can use the same graph data within the view designer. We can also do a little bit of math within Log Analytics itself. Now, Log Analytics has its own basket functions and machine learning stuff, but this is just, generic math right here. What I've done is written an estimation of how long it'll take for this food to be done. If I run it right now, it says we have about 26 minutes left because our current food temp is at 121 degrees and our target temp is at 145. I've actually found that pork roasts seem to cook at about one degree per minute at the 300 degree pit temperature. But what I've done is created 3 different queries here, where the first query we get our pork roast, we get the last one by time generated. We create a new field called current temp, which equals the food 1 temp. We extend target temp equals food 1 target, and then we project our current temp, the target temp, and the cook name. And then we do the second query where we get our pork roasts. We project our food 1 temp and the time generated. And we get the top 10 by time generated in descending. And then we summarize the max food temp minus the min food temp divided by 10. Now I'm dividing by 10 because I know I'm submitting this every 1 minute, so I'm trying to get the last 10 and then divide it by 10 minutes so that I have an average over the 10 minutes. We then extend cook name equals pork roast, and then we join query 2 with query 1 on the cook name. Whenever we do join, the first thing is that unless it's specifically specified, it's considered an inner unique join, and then you have to join it on some sort of common key when you do an inner unique join. Then finally, we do an extend to int, because I didn't want a bunch of decimals behind it. I just wanted to get, 26 minutes left. I extend a new field, minutes left, which equals the target temp minus the current temp divided by column 1, which is our average. So we have that. We can also do our alerts. And this is probably not going to work because I don't think I'm within 10 degrees yet. Nope. But what I've done is I've actually added this into Azure Alerts, and I'll show you that in a sec. And then I get an email when my food is almost done, and then I have the same thing for when food is done, when they equal each other. Another thing we like to do with all this data is to make some pretty dashboards with it. So if we head on over to the View Designer, we can do donuts, we could do line charts, we could do 2 timelines, we can do a few things. It's not totally it's not as many tiles as I would like, and during the Azure Monitor AMA last week they did say that giving this an update is on their priority for the first part of next year. So that'll be nice if they can give us some more options for dashboards. But for now, I'll use a donut, and it should pop up here. There we go. And then I will paste in a query that I have, and I will give it our pork roast. And so what do a percentage of that. What this query is doing is actually just getting the target temperature and the current food temperature. And if we select percentage here, it should do that math for us. There are some quirks with the View Designer where it doesn't always work right away, or sometimes you need to refresh the browser after you save. So what we have here is this overview tile, and then we can build further dashboards that when someone clicks on it, it will show further information. We have all these other dashboard types that we can do. Right now I'll select this line chart right here and see if we can't graph our cook. I have another query, just the same graph one that I showed you previously, that I'll paste in. And then I'll hit apply, and that looks pretty good. What we can do is hit close. I'm going to leave this as it is currently, but we can hit save. And then when you go back to overview, and you click on your overview tile, you can click in and you'll see all the different tiles that you've set up if you set them up. And sometimes it defaults to custom. For here, I'm going to set it to the last 30 minutes so that the graph actually loads the whole. There we go. So you can see we're getting close to done. In about 3 degrees, I'll see if I can generate that alert. But for now, if we go over to our alerts, I can show you how I set that up. So if we click on New Alert, it'll take us through this process. It's fairly simple. It'll select your Log Analytics workspace unless you haven't done it previously. And then you just go in there and select it. And the key part here is adding the alert criteria. The cool part is you can either paste it in if you have it, or it also reads from your workspace. So pork roast almost done is the one I want to use. And then I want to set our threshold to 1, because if it generates 1 or more times, I want to get alerted on that. And up here is what it's doing is actually reading the logs live to see if there's any currently that would trigger this alert, and it shows you the signal logic. And down here we can generate our, down here we can set our period in minutes and frequency in minutes, and 5 and 5 is fine by me. So I'll hit done. We can define our alert rules. And I'm not going to make that a seb1 because it's just an information alert, right? And then I'm going to suppress because I only want 1. And next we have action groups, which is really where the action happens. I'm going to create a new one just so y'all can see that, because the cool part is you can actually do a whole bunch of things other than just email or SMS. So like I said, you could do email, SMS, push voice, and that's cool. But for real world scenarios, you might want to run an Azure function, logic apps, send a webhook, open a ticket in your ITSM, or you can run an Azure Automation Runbook. And for this scenario, I could actually run an Azure Automation Runbook to a hybrid worker to my house on my lab server, and then send a post data to turn the pit off, shut down the fan, or change the temperature if I wanted to. And so that's really cool. So you can configure the runbook and do all that stuff. I'm not going to do that right now. I'm just going to cancel out. And then I'm going to see if I can go back and show you that alert. So I believe we should be within the 10 degrees so that this should actually return true. And it is. So we can see that we're within 7 degrees, so we're actually accurate there. And this would generate an alert. I should have an email within a few minutes. And with that, that's all I had for you guys today. Remember, you need the OMS Ingestion API PowerShell module, which you can install via install module. You need to build a valid JSON payload. Think about that payload so that you can write more efficient queries by separating out data. You can follow me on Twitter at scautomation. My blog is systemcenterautomation.com. I also have video content at techsnips.io, and the 2 posts in particular that this video covered are listed there. Thank you for watching.